review about chapter 4. First is some basic properties of log. Log base a equals 1, and log base a 1 equals 0, and log base a x plus log a y equals to log base a x y. And then log base a x over y equals to log base a x minus log base a y, and the next one is log base a x over log base a y equals to log x y. The log a base a and a to the x equals x. A times the log base a x equals x. Okay, let's do some examples. First is the question log y equals 9 log x. So log y equals log x and to the 9 here, and to log x to the 9. So y equals x to the 9. That's the basic. Next, natural log y equals 1.5x plus 39. So inverse this equation, it becomes e to the 1.x plus 39 equals y. So e to the 1.5x times e to the 29 equals y. 39. Sorry. And then we can find y.
Okay.
Next is about log transformation. Here are 3 steps. First, graph scatter plot x, y, height, and r. Second, let list 1 and list 4 in the calculator equals log and all the natural log of log list 1 or 2 or list 2. And the third step, graph list 1 versus list 3 or list 4 and all the residuals. We can review on page 205 to 2. Next is about the exponential and power equations about the log. First, the exponential. Here is the formal equation about y equals to a to the x. Next is two examples, y equals 2 to the x and y equals to 4 to the x. And the power equation, here is the formal equation, y equals to x to the a. And here are 2 examples. Let's talk about correlation. Actual correlation is use regression line to predict values outside of data. Here's the example. So the question is how many miles will be run after 30 days? 40 days. We can't see the data on the graph, so we need to predict the data. First, we can find the regression line of this, and then plug in 40 to the regression line, then got the miles run. So this is the actual correlation point. Here are some diagrams about the relationship about the x and y. Here, x may cause y, it's called causation, and x may cause y, but z also can affect x and y. Is called a common response. Next is about x may cause y and z may cause y too. So z is a confounding variable. Next is about lurking and confounding variable. Lurking variable is the variable that affects both exponentially and the response. Confounding variable is the variable that which causes the exponential variable. The lurking variable, here's the example. The sales of gasoline is rapidly increasing, which causes to rapidly increasing carbon dioxide emissions. It's not true. Lurking variable actually is more people need more cars. Sure.
Next one.
Confounding variable. Here is example. Fossil fuels may cause carbon dioxide emissions, and more people their habits may also cause carbon dioxide emissions. So more people own more fossil fuels. Carbon consumption could lead to increased emission. So those are both conflicting variables. Here is a question about high school student math students. Here's the chart. It's divided by male and female students taking math classes. The question is about what percent of males take math. So we can first find that the total male students taking math is 182, and total students taking math is 374. So you can get this number. 132 divided by 374, get 38.6.
48.6%.
We have 48.6%. And the 1% of females taking math. So use the total female students taking math divided by total students taking math. So we can get 51.3%. Next question, what percent of males have a class above pre-calc? So find the male students taking math classes above pre-calc class is calc plus stats, which is 31 students.
41.
Total. 61 students total, and divided by total male math students, so we got 33.5%. And next question, what percent of females taking class below pre-calc? So see the chart below the female students taking course below pre-calc, 22 plus 38 plus 36, and divided by total female students, get 50.1%. Okay, this is review about chapter 4.
Bye. Oh yeah.